Hello everyone. Today we'll start with the chapter Electrochemistry for class 12th. So we'll start with basic terms first, like what is a cell. So a cell has three components basically: a cathode, basically two electrodes and one electrolyte, and electricity is flowing through that electrolyte. So anode is an electrode. Anode is a negative or reducing electrode. Basically, in a cell, there are two electrodes and electrolyte, as you can see in this figure as well. One is anode, another one is cathode. So on anode, there is oxidation. Oxidation is basically release of electrons, and on cathode reduction happens. Okay, the reduction is basically gain of electrons. So the anode loses electrons and the cathode gains these electrons, and we have a battery in between the electrodes that creates the potential difference. So that's how the flow of electricity is maintained, and the conductance in the cell is maintained via electrolyte that allows the flow of electrolyte. Okay, so anode is a negative or reducing electrode that release electron. Basically, oxidation happens on anode. Okay, and during and electrons to the external circuit and oxidizes during the electrochemical reaction, while a cathode is a positive or oxidizing electrode that acquires electron. Basically, reduction is gain of electron. So cathode gains electron from the external circuit and is reduced during the electrochemical reaction, while the electrolyte present in the cell is the medium that provides the ion support mechanism between the cathode and the anode of the cell. Electrolytes are often thought of as liquids such as water and other solvents with dissolved salts, acids or alkalis that are required for the ionic conduction. So basically they conduct the flow of electrons between the cathode and anode. They provide the medium. Coming to the types of cells. Generally, they will study about two main cells. These are galvanic cells and the other one is electrolytic cell. So the basic difference between the galvanic cell and the electrolytic cell is that the chemical energy is converted to the electrical energy in the galvanic cell. That means some chemical reaction will produce electricity. While in the case of electrolytic cell, electricity is used to carry out some non-spontaneous reaction. Let's say A and B has a tendency to react. It is a spontaneous reaction. Delta G is negative for this reaction. So since the delta G is negative, so the reaction is anyway going to happen and it will produce some electricity. That will happen in galvanic cell. But let's say if A and B are non-spontaneous, delta G is positive. So in order to carry out such non-spontaneous reaction, we need to provide some extra force. That extra force will be provided by providing electricity or electrical energy that will carry out the reaction a non-spontaneous reaction A to B with that external force. Coming to the electrochemistry. Electrochemistry is a branch of chemistry where we study the production of electricity from Energy released during the spontaneous reaction. That means galvanic cell. In galvanic cell, some spontaneous reaction occur. Delta G for the reaction is negative. It is spontaneous. It will anyway react, and that's how the release energy will be released. Electrical energy will be released. So we'll study the production of electrical energy from the chemical energy. And on the other hand, we'll also study the electrolytic cells where electrical energy is used to carry out some non-spontaneous chemical reaction. Okay, so electrochemistry will study that a spontaneous reaction could release to the could lead to the release of energy, while we could provide some energy to carry out some non-spontaneous reactions. So why electrochemistry is important, as I have already told, is, let's revise that again. A large number of metals, like or sodium hydroxide or chlorine, fluorine, and many other chemicals are produced by the electrochemical methods. Sodium hydroxide, basically the chlorine gas, or the we can say sodium hydroxide are generally produced by the brine solution. Electrolysis of the brine solution is NaCl solution, saturated NaCl solution. So the electrochemistry of this solution, the electrolysis of this solution will release to the formation of the chlorine gas, and the sodium hydroxide will be released as well. And apart from this, we apart from generating some important these large number of metals or some important chemicals like sodium hydroxide, chlorine, there are other reasons as well, like batteries and fuel cell convert chemical energy into electrical energy and are used to on large scale in various instrument and devices. So the batteries and the fuel cell that we are using in our daily life, they are all based on the electrochemistry. So that's why the field is important to understand. The reactions are carried out electrochemically can be energy efficient and less polluting. This is also true that if you are generating electricity by burning coal, you are running the turbines, and by running the turbines you are generating electricity. So the by burning the coal you are releasing carbon dioxide and other harmful gases like NO, etc. The greenhouse gases you are releasing. But if you are doing the electrochemistry or using some chemical reactions to produce electricity, that won't generate so much of the side products. The side products that are generated in the case of burning of coal won't be generated there. So that's why the electrochemistry is important, as it is a greener way to generate electricity. Coming to the basic terms, oxidation and reduction. Oxidation is basically, you can say, release of electrons, and reduction is, you can say, in the terms of electrons, I am saying reduction is gain of electron. So let's say A gains electrons and forms A minus. The process is called gain of electron is called reduction. While example of reduction could be, say, sodium ion gained an electron, form a sodium metal. Okay. uh, this the reaction written over here is a reduction reaction, while oxidation is a reaction where, like, B forms B positive ion and one electron is released. This process is called oxidation. There is release of electrons. Let's say in a chemical reaction we say, like um, let's say sodium chloride. If we are doing the electrochemistry for this, sodium has a tendency to release electrons, Na plus an electron. Chloride on the other hand will gain an electron and generate Cl minus ion. If you combine the both, first one is oxidation and the second one is gain of electron, that is reduction. If you combine both the things, that is Na plus Cl gives electron got cancelled, gives NaCl. Here sodium is in this solid state and there is half Cl2 molecule that generated half Cl minus ion. So sodium plus half Cl2 gaseous molecule will generate sodium chloride. Okay. So oxidation is defined as a loss of electrons, as we have seen that A will generate A positive ion and electron. This is process is called oxidation, while reduction on the other hand is defined as gain of electron. Okay. In a redox reaction, redox, from the term itself you can see redox is consists of reduction plus oxidation. Both reduction and oxidation reaction takes place simultaneously. Okay. Direct. Now let's understand what are direct redox reaction and what are indirect redox reaction. In a direct redox reaction, both oxidation and reduction takes place in the same vessel. That means in one electrolytic cell only containing two electrodes, reduction will happen on one electrode and the oxidation will happen on one electrode, and they both electrodes are in common vessel or common cell. They are sharing only one electrode, one single electrolyte they are sharing. Okay, electrolytes. While in the case of indirect redox reaction, oxidation and reduction takes place in different vessels. You can say, let's say the one electron is in this one, another electron is in this one, and the both the electrodes are connected by a salt bridge to allow the movement of ions from one electrode to the other. So these kind of redox reaction where the both the electrodes are not sharing common electrolyte, these are called indirect redox reaction. In the direct redox reaction, chemical energy is converted to heat energy in a direct redox reaction, while in the case of indirect redox reaction, chemical energy is converted to electrical energy, and the device which converts chemical energy into electrical energy is known as electrochemical cells. So basically in electrochemical cells you will see these kinds of indirect redox reactions. Now coming to the electrochemical cell. An electrochemical cell, we have understood till now that a cell consists of two electrodes. One is the anode, another one is the cathode. So on So we have till now understood that in an electrochemical cell there are two electrodes. One is cathode and another one is anode. The half cell in which oxidation takes place is called oxidation half cell. Let's say this one is oxidation half cell. The other one is where reduction will takes place. This one is called reduction half cell. Okay. The first one where oxidation will happen is called oxidation half cell. The other one where reduction will happen is called reduction half cell. The oxidation takes place at anode. Let's say we call it as anode. Here oxidation will occur. This one is cathode. Okay. Oxidation occurs at anode. It is negatively charged, or you can just use lone formula. Lone is just a mnemonic for this. Left side you just write left side you write anode. Left side oxidation will happen. It will happen on anode, and that too is negatively charged. So anode are negatively charged while cathode electrode is positively charged. Okay. Transfer of electrons takes place from transfer of electrons takes place from anode to cathode. Since on anode there is oxidation, electrons released. So cathode electrons are gained. So transfer will occur from anode to cathode. Now here electrons are released, here electrons are gained. So electrons are the movement of electrons is from anode to cathode. But electricity or current flows in direction opposite to the direction of movement of electron. In direction opposite to movement of electron. So this is the flow of electron, the direction, while electricity on the other hand will flow from cathode to anode. Okay. An electron is made up by dipping a plate into the electrolytic solution. As you can see, these are two electrodes which are dipped in the electrolytic solution. The electrodes are could be of metal plate or could be a rod, metal rod. Okay. And the both the cells in the electrolytic cell, both the cell that is oxidation half cell and the reduction half cell, these are connected by a U-shaped bridge that is called an salt bridge. The middle one is called salt bridge. It basically allows the movement of charge or between the two cells. And in the U-shaped tube that is called this salt bridge, basically salt bridge contains inert electrolyte. Why it contains inert electrolyte? Because it should not react with the ions that are oxidizing or reducing in the electrochemical cell. Otherwise, it will affect the chemistry. So the electrolyte that is to be used in the this salt bridge must be inert electrolyte, and that too in agar or gelatin mixture. So basically, agar and gelatin mixture are like they provide the uh, hard, you can say, hard mass for the electrolyte to stay. If you don't provide agar and gelatin, the salt bridge will like lose the electrolyte. The electrolyte will flow in the both the electro half cells. If you provide gelatin or agar medium, then the electrolyte will be going to be stay in that tube only. So salt bridge, as I defined, salt bridge maintains the electrical neutrality. Salt bridge is a U-shaped tube that connects the two half cells. These connect the U-shaped tube that contains uh, that connects the two half cell, and the electrolyte used over here should be inert. That too in a mixture of some hard mass, mixture of hard mass like gelatin और अगर अगर. So function of salt bridge: connects or completes the electrolytic cell. It maintains the electrical neutrality, and it also allows flow of electric current, that I have said that it completes the electrolytic cell circuit, electrical circuit. Okay, so in the following figure you can see that zinc sulfate is the salt present in the one cell, while in the other one copper sulfate is present. So since it is present in the anodic half cell, so the zinc is going to do oxidation. Zinc 2 plus 2 electrons will be released, while on the other hand copper sulfate from the solution, this zinc metal is going to oxidize zinc solid, and the zinc sulfate, the zinc is released in the electrolytic cell. Okay, while copper sulfate from the solution in the aqueous form will gain 2 electrons and will form copper metal. So here the metal will be deposited on the electron, and while the in anode the electrode will undergo oxidation. Okay, and the both the electrolytic cells are connected by a salt bridge containing potassium chloride, and here you can see the zinc 2 positive ions are released. Since the zinc 2 positive ions are released, they need to be counterbalanced. So the chloride over here will allow the movement of see, copper 2 plus are going over here, the sulfates are free. These sulfate will move to this solution and will combine with the free zinc positive ions to form zinc sulfate. Okay. Representation of an electrochemical cell, you have already seen the previous video as well. Electrochemical cell representation, easy to remember, is lone. So whenever you are supposed to write, let's say you have this electrochemical cell, zinc sulfate plus copper undergoes, or we can say, let's say we have copper 2 plus and zinc. So what will happen? Zinc will convert into zinc 2 plus and copper will get reduced. So how are you supposed to write this chemical reaction? Here zinc is undergoing oxidation and the copper is undergoing reduction. Zinc plus copper 2 plus will give you zinc 2 plus copper. So how will you write the notations for a electrolytic cell? The notation could be written like this: zinc will undergo oxidation to form zinc 2. This is oxidation half cell. In between there will be a salt bridge, and then there will be a reduction half cell. Reduction, copper will reduce the copper solid. Okay, this is reduction half cell. Left side, why we have written oxidation on the left side? Because it is the notation that is to be followed. Left side oxidation will happen, so the oxidation reaction will be written left side of the salt bridge. Salt bridge is represented by these two parallel lines. So the salt bridge, this represents a salt bridge. Okay, Anode is written on the left side while cathode is written on the right side. We have already understood that. And anode represents the oxidation half cell written as metal ion. In the case of zinc, uh, going from zinc to positive plus 2 electron, how are you supposed to write? Zinc solid slash zinc to positive aqueous. Okay, this is the oxidation half cell. Similarly, reduction half cell, for example, copper 2 plus will gain 2 electrons and form copper 2. How you are supposed to write? Copper 2 plus aqueous slash copper solid. These two half cells are connected by placing vertical lines in between. Vertical lines represents a salt bridge. So overall, you can say you will write zinc 2 plus uh, zinc slash zinc 2 plus aqueous. This is in solid. In between there are parallel lines for salt bridge. Then a copper 2 plus ion in the electrolyte that is converting into copper solid. Okay, that's how you present the cell. Zinc solid will convert into zinc 2 plus. In the brackets you can write the concentration, while in between there is a salt bridge, and then we have copper 2 plus ion in the electrolyte which is converting into copper solid. Okay, so here metal which is getting oxidized is zinc. Left side oxidation, you can see this is oxidation part, this is reduction part. Metal which is getting oxidized is zinc, it is converting to zinc 2 positive ion. The copper 2 plus ions are getting reduced to the copper metal. This is called reduction half cell. First one is called oxidation half cell, and they are connected by a salt bridge. Coming to the next term, that is electrode potential. So what do you mean by electrode potential? Electrode potential is the potential difference that is developed between the electrodes and its electrolyte. Okay, the separation of charge at the equilibrium state results in the potential difference between the metal and the solution of its ion. It is a measure of tendency of electrode in the half cell to lose or gain electrons. What does this mean? This means that it is the potential difference that develops between the electrode and the electrolyte. So what does it mean that if the potential difference which is developed? As here you can see, in the anodic compartment there are zinc positive ions. Zinc positive ions are released from the zinc anode or zinc electrode which is getting oxidized. Zinc electrode is converting into zinc 2 positive ions and releasing 2 electrons. Here you can see zinc anode, zinc electrodes in the solid form is converting into zinc 2 positive ions plus 2 electrons. So in the this salt bridge you have put sodium nitrate. So the zinc 2 positive ions are combining with the nitrates from here and forming zinc nitrate, while the electron release goes to the electrical circuit, and here you can see there is cathode which is hydrogen electrode, standard hydrogen electrode. With respect to that, always electrode potential are measured with a reference, and that reference is taken as standard hydrogen electrode whose potential is assumed as 0. It is taken as 0, that means 2H plus by gaining of 2 electron forming hydrogen gas. So the delta E naught for this cell, E oxidation for this cell is considered as 0 volt. So with respect to this 0 volt, The measured potential in the voltmeter will tell the tendency of the zinc to lose the electrons. Since the potential over here is 0 volt, E cell we can say E cell is equal to E anode minus E cathode. Cathode where reduction happens, for hydrogen it is 0, for anode it is 0.76. That's why for the whole cell we are seeing the potential of 0.76 volt. Okay, that's how you are supposed to calculate the electrode potential. Electrode potential are always calculated for the metal or the salt in reference to the hydrogen electrode. Okay. Standard electrode potential. Standard electrode potential can be defined as when the concentration of all the species involving in the half cell is unity, then the electrode potential is known as standard electrode potential. It is denoted by E naught, or you can say the actual symbol is this thing. So it is when the concentration of all the species measured present in the cell is one or unity, then we can say that the potential measured is E naught. According to the present convention, standard reduction potential is now called standard electrode potential. So there are types of electrode potential: oxidation potential and reduction potential. Oxidation potential is the potential where the A metal is converting A plus plus electrons. For this reaction, the potential is E oxidation, while for the reaction like B plus plus electron giving B minus, for this reaction the potential is E reduction potential. So the reduction is happening. Oxidation potential is a tendency of electron to lose electrons or to get oxidized, while the reduction potential is the tendency of the electrode to gain electron or to get reduced. Okay, and generally or always E oxidation is reverse of E reduction. They are opposite to each other. Opposite means you can just put a negative sign and write the E oxidation value as E reduction value by just putting a negative sign. Oxidation potential is the reverse of reduction potential. As I just said, that E oxidation is reverse of E reduction. The electrode having a higher reduction potential have higher tendency to gain electrons, and so it acts as cathode, while the electrode having a lower reduction potential act as anode. So what does this mean? This means, let's say you have a chemical reaction A getting oxidized to A plus plus electron. So E oxidation for this reaction is, let's say, 2.3 volt. 2 volts, just for the simplicity of calculation, let's say it is 2 volt. B, which is undergoing reduction, the value is E reduction is 4 volt. Let's say it is 4 volt. Overall reaction, you will say that A plus B plus gives you A plus plus B. Okay, overall reaction is this. So for the overall, the cell potential is basically E cathode minus E anode, or you can say E reduction plus E oxidation. The value to be written over here should be in the reduction form only. So the E oxidized will be written as E reduction. Then we can write this as minus 2.0 volt. As E oxidation is equal to negative E reduction, we can write E reduction for this reaction as this. So E cathode is reduction 4 volt minus E anode. E anode in the form of reduction value you have to write, that is minus 2.0 volt. The whole value will be 4 plus 2. E cell will be 6 volt. And please remember, like, if delta G is negative, reaction is spontaneous, and if delta E is positive, then reaction is spontaneous. So here you saw the value comes out to be plus 6 volt. That means the cell is just going to work spontaneously. Okay. The standard electrode potential of an electron can be measured in isolation. It is always measured in reference to hydrogen or standard hydrogen electrode. According to the convention, standard hydrogen electrode is taken as a reference and it's assigned as a potential 0 at all the temperatures. So reference electrode could be the electrode like standard calomel electrode can also be used for the reference electrode apart from the standard hydrogen electrode. So what is a standard hydrogen electrode? Standard hydrogen electrode consists of a platinum wire. You can say a platinum wire is there which is sealed in a glass tube. So this wire is sealed in the glass tube, platinum wire, glass tube, and carrying a platinum foil at one end. So there is this platinum foil at one end. The electrode is placed in a beaker containing an aqueous solution of acid. So this electrode is placed in a beaker that contains a solution of 1 molar acid H plus ions, 1 molar H plus ions. Hydrogen gas at 1 bar pressure is continuously bubbled through the solution. So here hydrogen gas is also bubbled. Bubbling is there. The bubbles are maintained. So you are providing hydrogen gas at temperature 298 Kelvin, that is at room temperature 25 degrees Celsius. The oxidation and reduction takes place as platinum at platinum foil. So what is happening? H2 gas that you are providing is converting it into two H plus ions plus 2 electrode, while the H positive ions present in the form of this acid in the electrolyte are gaining 2 electrons and converting into H2 gas. So this is the overall reaction that is happening. If the standard hydrogen electrode act as an anode, then the reaction it could act as anode and cathode. As I said, if it is acting as anode, then the gas hydrogen bubbles that are added, that will convert into H positive ions and the electrons will be released. And if it is acting as cathode, then the ions present in the electrolyte 1 molar H plus solution will gain electrons and will convert into H2 gas. In the electrochemical cell, various elements are arranged as per their standard electrode potential. A substance with higher reduction potential value means that it has a higher tendency to get reduced. So it acts as a good oxidizing agent. A substance with a lower reduction value means that it has a higher tendency to get oxidized. So it is a good reducing agent. The electrode with a higher reduction potential act as a cathode, while the electrode at a lower reduction potential act as anode. So the potential difference between the two electrodes of a galvanic cell is called cell potential and is measured in volts. The cell potential for a reaction is basically measured by the formula E cathode minus E anode, where you are supposed to write E cathode in the form of E reduction and E anode in the form of E reduction. Okay. So as you can see, higher the reduction value, these are the E reduction value for all the cells. Higher the plus 2.8 plus 1.7 plus 1.15, higher the reduction value means strong oxidizing agent. Strong oxidizing agent means they will itself get oxidized, they will itself get reduced and will oxidize the other other iron over the other metal. While stronger, weaker the reducing, or you can say lower the reduction values, the negative value over here. Uh, the more negative, that means stronger reducing agents are there. They will reduce the other one or itself gets oxidized. Hydrogen, on the other hand, is in between, and the value taken for hydrogen is 0. So now we'll do some questions. So here is one question for you. Calculate the cell potential of a galvanic cell that uses the half cell reaction mentioned below. Please calculate the cell potential for the reaction. I'll give you 2 minutes. So, how you are supposed to solve this reaction? In this reaction, you are mentioned the E reduction value for the two ions. So, which one will act as cathode and which one will act as anode? Ultimately, a reaction is spontaneous. It is galvanic cell, no? The reaction has to be spontaneous and will produce electrical energy, so that for the reaction to be spontaneous, E cell should be positive. Now you tell me that if you are going to do the E cathode minus E anode, E cell is basically E cathode minus E anode. So which one will act as cathode and which one will act as anode? Higher the reduction value means it will act as cathode. Silver will act as silver ions will get reduced to silver E cathode, while the magnesium will undergo oxidation and will form this. Since the electrons are not same, so we are going to multiply it by 2. That means we'll be having 2 silver positive ions plus 2 electrons, giving 2 silver metal and 2 silver metal, while one manganese metal is undergoing oxidation to form one magnesium ion plus 2 electrons. So overall reaction for will be 2Ag2 plus Mg will give you Mg2 plus Ag. The 2 electrons over here, 2 electrons here will be cancelled. For this overall reaction, E cell will be E cathode minus E anode. So which one acted as cathode? The silver one. The silver cathode value is plus 0.80. 0.80. E anode is manganese one. Manganese value is minus 2.37. So 0.80 plus 2.37 will give you 3.17 volt. That is our answer. So I hope you guys understood. Please pay attention and check your answers. We'll do the one, two, three more questions regarding this. Coming to the next question. Calculate the E cell for the following reaction. For the following half cell reactions. I'll give you 1 minute. Please do it. So, uh, for a galvanic cell, the E cell is supposed to be spontaneous. That means it has to be positive. So which one of the following half cell will act as cathode and which one will act as anode? So higher the reduction value, more is a tendency to get reduced. Okay. So out of the two, minus 0.23 is more. So nickel will undergo reduction and will act as in the reduction half cell, while iron on the other hand will undergo oxidation to form iron 2 plus 2 electrons. So overall we have nickel 2 plus iron giving us nickel solid plus iron 2 plus as a overall reaction. So E cell will be E cathode minus E anode. E cathode over here is nickel 1. So the reduction value for nickel 1 is minus 0.44 minus E anode is minus 0.23. It will give you minus 0.44 plus 0.23. Okay, we did some mistake over here. So over here, actually, the the iron one is going to do reduction. Iron 2 plus 2 electrons, while nickel will undergo iron 2 plus will undergo reduction, oxidation, sorry. So overall you are supposed to say E 0.23 minus 0.44 minus 0.23 plus 0.44. The value will come out to be 0.1121 volts. That is positive. So how we are supposed to guess this? We are supposed to get this if we are taking E cathode as nickel 2 plus, nickel 2 plus 2 electrons giving you nickel, while E anode as iron getting into iron 2 plus 2 electrons, nickel 2 plus iron giving you nickel plus iron 2. So over here cathode is iron, this nickel 1 is E cathode, so the value is minus 0.23 minus E cathode is iron and it is getting converted into iron 2 positive ion. So the overall E cell value is 0.21 volts. Do this next question, please. In this reaction, bromine is undergoing reduction. Br2 plus 2 electrons will give Br minus 2 Br minus ions, while iron will undergo iron will undergo oxidation to give iron 3 plus 2 electrons, 2 iron 2 such minus ions, 2 iron Fe2 ions will undergo this oxidation. So overall we will be having Br2 plus 2 Fe2 positive. These two electrons will be cancelled and you will be having 2 Br minus plus 2 Fe2 plus. So E cell for the reaction is E cathode minus E anode. Here E cathode that undergo reduction is Br2 converting into Br minus ion, and E anode, this E anode is iron 2 positive is converting into iron 3 positive. But the this value is 1.09 minus 0.77 volt. Then you will be getting E cell as plus 0.32 volts. Okay, plus 0.32 volts. Do one more question. Calculate the cell potential for the electrolytic cell. The E reduction value for the half cell reactions are given. In the following reaction, you can see 2I minus ions are getting oxidized to I2 plus with the release of 2 electrons. So this one is acting as anode, while aluminium 3 plus ions are gaining 3 electrons and are converting into aluminium solid. This is acting as cathode. In order to balance the electrons, you need to multiply it by 3 and you need to multiply this reaction by 2. So overall you will be having 6I minus are converting into 3I2 molecules with the release of 6 electrons, while 2 aluminium 3 plus ions are gaining 6 electrons and are converting into 2 aluminium solid molecules. So you will be having 6I minus plus 2 aluminium 3 plus ions converting into 3I2 molecules plus 2 aluminium molecules. So the E cell for the reaction is E cathode minus E anode. E cathode, you can see aluminium getting reduced is the cathode over here, cathode electrode. So we'll be writing E cathode value, that is minus 1.66 volt, minus E anode over here is plus 1.0.54. So for the electrolytic cell over here, we got a value of minus 2.2. Okay. So we have understood that E cell for the reaction is E cathode minus E anode. The cell potential is called electromotive force of the cell, or you can say that the EMF when no current is drawn to the cell. In the following videos or in the next part of the video, we'll also discuss the nurse equation. The nurse equation basically studied the variation of electrode potential of the cell with temperature and concentration. This is the nurse formulation relationship between the standard electrode potential E naught and the electrode potential E. So the nurse equation is as follows: E cell for the reaction is equal to E naught minus nRT RT by NF, sorry, RT by NF ln K. Okay, this is the nurse equation. If you are putting the this ln, you are converting into log, then E cell is equal to E naught minus 2.303 RT log K by F, or NF. N is the number of electrons involved in the reaction, F is the Faraday, R and T are, R is the gas constant, T is the temperature, and K is the equilibrium constant, you can say. That will define as the, if you are saying like A plus is plus B is converting into A plus B plus. Okay, so the cell constant for the reaction, or equilibrium constant for the reaction is A, a product of the concentration of the products, while the product of the divided by the product of the concentration of the reactants. So this is defined as the equilibrium constant that you are supposed to substitute in this reaction over here. Okay. We'll discuss this in detail in the next video, and we'll also solve some examples. Electron potential increase in the concentration of the electrolyte and decreases the temperature. We'll study all these factors. Nernst equation, let's say we'll just study for now only. Let me tell you one more time. Let's say if you have a reaction A giving A plus electron. This is the oxidation reaction. B taking electrons is converting into B minus. Overall reaction, you have A plus B giving you A plus B minus. So the Nernst equation says E is equal to E naught minus 2 RT by NF ln K. K, you have seen that K for this reaction is the product of the reactants, product of the products divided by the product of the reactants. So you are supposed to write A positive, B negative over A and B ln minus RT by NF E naught. Number of electrons involved in the reaction are 1. E is equal to E naught. R is the gas constant, T is the temperature, F is the Faraday constant. So if you are putting all the values over here, then its value comes out to be 0.0591. Okay, and divided by N. N is 1. So 1. The three values over here at 298 Kelvin. Temperature, if it is 298 Kelvin, at RT the value will come out to be 0.059 ln. I have also multiplied ln to the log, so I also multiplied 2.0303 over here. So it will give you A plus B minus over A. So that's how you are supposed to calculate the value, and you will get the Nernst equation. At equilibrium, and we can also say that at equilibrium this E cell will become 0 and you will be left with 0 is equal to E naught cell minus 2.303 RT by NF L log anode ion over cathode ion. So E naught cell is equal to 2.303 RT by NF log anode over cathode. This is a relationship at RT. You can see, and from this you can also calculate the Gibbs energy, that is delta G is equal to minus NF E naught cell. So if you are putting E naught cell value in this one, you can also calculate the delta G energy. We'll do some questions further for this last equation in the further part of the video. Um, Thanks for cooperating. We'll move to the second part, and then we'll solve those questions. Thanks for watching.